Overload results from static or shock loads and leads to plastic deformation. Now, this can be recognized by depressions at rolling element distance. Often, wrong mounting procedures are at the base of the problem. In other words, applying the mounting force to the wrong ring and thereby producing a shock load over the rolling elements. Indentation from debris results from foreign particles or contaminants that have gained entry into the bearing and which are rolled into the raceways by the rolling elements. The size and shape of the dents will depend on the nature of the particles. The raceway geometry at the dent is destroyed and lubrication is impaired. Stresses arise at the surface and fatigue leads to premature spalling of the surface. Indentation from handling can occur when bearing surfaces are gouged by hard, sharp objects. Also, bearings must always be handled with care. Although they're made of the highest quality steel, localized overloads, for example from dropping a bearing, might dent the surfaces and make the bearing unserviceable. Is caused by stress concentration in excess of the material tensile strength, by local overloading or by overstressing, and there are two common causes. One is rough treatment or impact when a bearing is being mounted or dismounted. For example, hammer blows applied to a hardened chisel directly against the ring may cause the formation of fine cracks, with the result that pieces of the ring break off when the bearing is put into service. Force fracture can also result from excessive drive-up on a tapered seat or sleeve. The resulting tensile stresses or hoop stresses arising in the rings produce cracks when the bearing is put into operation. Fatigue fracture starts when the fatigue strength is exceeded under bending. A crack is initiated that will then propagate. Finally, the whole ring or cage cracks. Fatigue fracture can occur when a tight fit has been used, leading to high hoop stresses. Then the combined Hertzian and hoop stresses can lead to premature fatigue and through cracking of the ring. Thermal cracking can occur when two surfaces slide heavily against each other. The frictional heat that's developed causes cracks, generally at right angles to the sliding direction. A bearing is made to take a certain load and to rotate at a certain speed, and so on. Do not put too heavy or too light a load on a bearing, nor rotate it too quickly. There's a large choice of bearings. It's important to select the one that fits the application and its operational conditions. Make sure as well that the right tolerances and fits are applied. Where applicable, make sure that alignment is within appropriate limits. A clean environment during the mounting process provides a good start for long bearing service life. Always use the appropriate tools during mounting or dismounting. Inappropriate tools might lead to early bearing damage. Make sure that the right sealing solution has been chosen and that it works effectively. Too little, too much, or inadequate lubrication can result in early bearing damage. Make sure that the right lubricant is applied at the right time and in the right quantity.